Dear students and participants on the course on railway engineering, we are back with a discussion on the signaling. In the previous lecture, we talked about the color aspect signals, and then we had taken up some specific signals which are used so as to receive a train on the station or within the station limits. We talked about the routing signals, and then we also talked about the departure signals. So, there were outer signals, home signals, starter signals, advanced starter signals, all of these things have been already taken up. And then after that we looked at the schedule of the aspects, wherein the combination of the distant signals, the inner distant signals, the outer signals, home signals, starter signals, advanced starter signals, and setting the things for the main line and the loop lines, they were discussed. Today, we are going to talk about the subsidiary signals. The subsidiary signals can be like the shunt signals, the calling on signals, the repeater signals, or the co-acting signals. Apart from that, there are certain indications which needs to be given to the loco pilots, and they are in the form of indicators. And these indicators can be related to points, speed, shunt, caution, stop, level crossing, grade, and many more other things. So, we will try to cover all of these things in today's discussion. Let us start with the subsidiary signals. Now, what are these subsidiary signals? These signals authorize the movement of the train at low speed only. So, wherever these type of signals are being shown, it means the train can move at a very restricted speed. The movement is within the station area, you are not in the block section. Unlike running signals, that the signals like stop signals, semaphore signals, or the permissive signals, these signals may authorize the loco pilot to move on to the occupied lines. Okay, so you may feel that how it is possible that depending on the movements and the efficiency to be maintained and utilization of track to be maintained, and because the trains are moving at a very slow speed, this type of authorization can be given. The visibility of these signals is not critical. In the previous lecture, we talked about what should be the minimum visibility of those signals. In some cases 2 kilometers, 1 kilometers, 400 meters, 200 meters, and so on. But here that is not a critical issue, because you are moving at a very slow speed, less than maybe 15 kilometers per hour, and therefore it is very easy for the loco pilot to concentrate and see where these signals are being provided and what is the indication which is being given by these signals. And there is no requirement of pre-warning. In those cases with the stop signal, we were using the permissive signals, the distant signals, the warner signals. Here that is not required. So, let us talk about the first type of a signal, which is a calling on signal. The calling on signal is what? It is used only for a specific purpose of indicating to the loco pilot to move the train ahead when it is in off position and when the train is in waiting beyond the home signal. So, it is saying, now you can come, you are waiting there, please come. That is the type of indication which are giving to the loco pilot. So, here in this photograph you can see at the top we have the main signals being provided, but here at this point there is a light and a disc is there which is having C written on it. So, there is a white disc, at the top of it black C is written. This is a definition, here it is a calling on signal. So, this calling on signal is saying you can come, and for whatever the light is being defined here, on the basis of that which particular track you are going to take, which loop you are going to take, that will also be defined. So, you start coming slowly and get into it. This is allowed even when the stop signal is in on position, but the loco pilot has to remain prepared to stop the train short of any obstruction. It is placed on the same post below the home signal. As I said, below the home signal we are providing it. The arm of calling on signal is smaller than the main semaphore signal. Now, here this is a color aspect signal which we have talked. Okay, so this is a CLS, color light aspect signal. But say if you are talking about a semaphore signal, in the case of semaphore signal, we talked about that there is a hand which will go up and down depending on in which particular quadrant it is working. So, it can also be provided with that, but in that case the size of the hand is going to be smaller. The size of the hand was not smaller when it was a semaphore stop and a Warner signal or a distant signal. It also helps in the movement of the train during the main signal failure, and the calling on signals are put to off position only after the train has come to a stop. So, first of all the train has to stop, then it says it is an off position, and if its position means now you can proceed. So, before proceeding it has to stop there mandatorily. These signals with color aspect are provided with a marker plate, as I have already shown to you. C is written on that, it is a white background and this is in black. The color aspect calling on signal has no independent aspect in on position, and it shows miniature yellow in the off position. So, if it is in an off position, miniature yellow light will come, but if it is an off position, nothing will come. That means we are not calling you, remain wherever you are. Then under special approvals, this signal can be provided below any other stop signal except the last stop signal. So, whatever is the last stop signal is there in that limits of the station, on that it is not going to be provided, but any other stop signal if it is there we can use it with that. It shall lock and detect all the points in the route including the isolation points, if any, which the main signal above it detects, excluding those in the overlap area. We talked about the overlap areas, station overlap area and the block overlap area, like 120 meters, 180 meters. In those particular areas if something is coming, we are not talking about it, but anything which is being detected by a main signal which is provided at the top is also being detected by the calling on signal. So, that means now they can work in unison. If they are not being combined together, then what will happen is this signal may say something else and the calling on signal says something else, and then there is going to be a confusion and it may result in a hazardous situation. Next, calling on signal requires all the level crossing gates. If they are there, they should get closed and locked against the road traffic before the train is going to move on that particular track on which the calling on message has been given. So, this is again another important issue. This needs to be taken care of, and obviously in the automatic system it will happen by itself. So, here you can see how these calling on signals looks like. So, this is a two aspect signal. So, in this case this is a main stop signal, a semaphore arm, but the calling on signal is a smaller size which is having a white total background and a vertical strip which is of color red. Here if it is going down, that it means you can proceed slowly. In the case of multi aspect signals where you can arm can go up, upper quadrant is being used. So, this is a stop situation because both are in horizontal position, but if it goes up it will show yellow color. See, if it is in a stop position, this is not showing any color here, whereas the stop, the semaphore signal is showing red. So, that is what it says, the miniature yellow will come only and only if a caution is being defined. So, that is where this yellow is coming here. Similarly, in the other case this is a light based system. In the light based system, if it is a stop, no color is coming at the calling on, this is calling on signal being provided. So, this disc says at the top of this disc whatever signal is, that is a calling on. But if it is proceeding slow, then this will turn to yellow. So, that is how the indication is coming on which particular track, on which particular loop line the train is being called at a particular station. The another type of signal is a shunt signal, which is very important for the operations which are needs to be done in the station yards. So, we are talking about those operations now, and obviously these all operations are being done at a very slow speed. These signals, they can be provided as an independent or a dependent form. Now, if you look in the photograph here, there is a calling on signal being shown, there is no light, it means it is on position, but below that here we are providing a shunt signal where an arrow is also being shown above that, and there is a definition plate being given at the bottom in a white color. So, this is a case where they are on the same signal. So, dependency is there. More than one shunt signal can be placed on the same post, but then in that case the definition plate will define in which particular line you are going to do the shunting. Where semaphore signals are used, these are provided in the circular disc shape. Disc is provided with a red band on white background. So, red band on a white background is how the disc will be provided. So, here you can see the disc. There is a white background, a red band is there, there are two holes. When it is in horizontal one, it is showing the red color. When it is being taken down at an angle, then it is showing the green color. So, that is an on and off position being defined, the stop or the proceed position being defined. So, it is provided with the two holes, one for red lamp, another for green lamp. It revolves in the vertical plane. The red band is horizontal, or it shows a red light during the night, then it indicates a stop. When the red band is inclined at 45 degree, or it is showing the green light, that means you proceed. The speed during these type of operations is limited to 15 kilometers per hour, as I said, and we started with it. In the case of subsidiary signals, the speeds are going to be lesser and they are all within the station limits. Now, when the color aspects are used, then how it works? You can see on the right hand side again a photograph is being shown where there are three lights, 1, 2 and 3. In this case, the two lights which are inclined in nature, they have been lit. So, what does that mean? So, it says the color aspect signals are used. These are provided with color light signals placed on a post. It is provided with three light lamps. When the two lights in horizontal plane are on, that means stop. So, if 1 and 2, so in that means if 1 and 2 they are on, should have been in a stop condition. Whereas it says when it is an inclined plane, then it is an on, and it indicates that you are in a proceed condition. Sorry, this will be off, not on. So, here you are talking about 2 and 3. So, those 2 and 3 they are on, that is indicating that you can come and proceed. Now, when the shunt signal is placed below a stop signal, it shall show no light in on position. So, if it is being correlated with the stop signal, as we have seen here that on the same one it is being provided, here there is no light, whereas the stop signal is saying you have to stop the train. So, that is what it is saying here. So, here you can see the combination, the horizontal direction, the two lights are on, and that is giving you an indication that you have to stop. If placed on the same post, then the shunt signal is placed below the stop signal and below the calling on signal, even if the calling on signal is also being provided. It shall not work simultaneously with the stop signal or the calling on signal. They are two different aspects. The calling on signal or the mainline signal or stop signal is talking about a train to move on a section. Here we are talking about a shunting. The shunt signals, they shall lock and detect all the points in the route and the track, excluding the berthing tracks, shall be clear. Okay, so it says that if as soon as it is being operated, the train is going to shunt, then all the points in the route, they are going to be locked and they are going to be detected. Detected means now everything is known on the control room and board. When the shunt signal is operated, then the level crossing gates also should get closed and there should not be a traffic moving on the road. And this happens when you are taking the train to the yards, and the yards are some 1 or 2 or 3 kilometers away from the main station area, and in between a crossing road comes, you need to provide a level crossing there. Then another type is the repeater signal, means the name itself says you are repeating a signal or indication which is already being given. Now, why this is required? This is required when a signal is not visible to the locopilot from an adequate distance due to curvature or due to any other reason, or it is also not visible maybe to the guard of the train who is controlling the movements at the rear end of the platform. So, there is some reason, say the it is a curved track and the platform is also provided in this form, and there is some signal being shown here. Now, because of n number of things which are happening in the platform area and the train is standing in this length, it may not be visible to the guard, or it may not be visible to the locopilot because of some other reason. So, for those cases the repeater signals are provided, and they are provided at a suitable location such that, say if we provide it somewhere here, now the visibility for the guard, or say if we are providing at some other locations, so the visibility to the locopilot will be there and they will understand and operate the train accordingly. They may be semaphore type, they may be color aspect type, they can even be a rotating disc type. And in these type of signals, when they are provided with a R marker. So, that means that there will be a disc on which R will be written, as we have seen in the case of calling on, it was C written on the white disc. So, you can see that there is a R, so it means these are the repeating signals, and it is on condition. So, you are stopping here, or an off condition you are moving. In the case of color aspect conditions, it is on and off, that means again R is being shown here. So, you have a yellow light and a green light, and if you are using the disc, horizontal means on and the inclined disc means off position. So, this is how, using either the semaphore system or a color aspect system or a rotating disc system, the information can be provided to either the guard or the pilot of the loco. Now, co-acting signal. So, we talked about a repeating signal, means the same information has been given at some other location, so that it is visible to the locopilot or guard. Now, what is co-acting signal? It is provided when a signal is not visible to the locopilot due to some obstruction such as overbridge, high structure, or to the guard of the train at the rear end of the platform. So, you have provided us a line and say there is a overbridge here, the pedestrian overbridge is there, and the height of this pedestrian overbridge is such that whatever the signal which is being shown here is not visible to the train and the driver or the loco pilot here, or to the guard. So, in such conditions, a co-acting signal means as soon as one signal gives some information, the other signal is also going to give the similar information, and that is why the name is co-acting. It is placed preferably on the same post, and it is the exact replica of the original signal. It works in unison with the original signal. That is why the name is co-acting. Now, let us talk about indicators. The very first one is a point indicator. Point indicator means that on a track, say we talked about that there is a line which takes you to the platform. So, the points are being provided. So, there is an indicator provided here which informs the loco pilot that you are approaching an indicator. There is an indicator at this particular point. There will be a movement either in the straight direction or a turnout condition. You need to be cautious for that. So, these indicates where the points are set for the main line or the turnout. It works as a precaution against the bursting of the points or the running into an occupied line. So, it will give you an information on the basis of the type of the color which is being shown. It is provided with an open box with two white rotating discs forming two opposite sides of the box, and along with the green bands on the remaining two sides. So, that is the type of a system being provided. On one side you can see this is the type of a rotating disc, whereas on other two sides there will be this green band. So, you can rotate. Okay, so, 4 sides are there, 2 sides with green, 2 sides with the white side. Box rotates with the change in the setting of points. So, this keeps rotating, and on the basis of this rotation the color codes will come. White disk indicates that the point is set for mainline, and green band indicates that it is set for a turnout. That is how the information goes to the pilot. That if you are seeing this type of a system, it means you are on the main line, but if you are seeing this one, that means you are on the turnout. So, such a beautiful way of providing the information here. Another is a trap indicator. The trap indicator is what? This is a device which is fitted on the track. In the open position, it derails the vehicle which passes over it. The trap indicator reveals whether the trap is in an open or a closed condition. In the open condition, the day indication is red target. So, this is a red target. In the night indication is a red light. So, a light will come which will be red in color. In the closed condition, the day indication is green target and the night indication is the green light. So, same way the other thing will be there. Now, this is a shunting permitted indicator SPI. So, the indication when the shunting is permitted in the direction to which it refers, and there is a day indication, there is a night indication. So, in the case of a disk type, it is black disk with a yellow cross painted on it. In the case of night indication, it is a yellow cross light. So, a yellow cross light will come. Then in the light type of a system, this is a yellow cross light or a yellow cross light in both of the cases. But if it is not being permitted, the indication when the shunting is not being permitted in the direction to which it refers, then it says in the case of disk type, the edge of the disk will be there in the case of day indication, and there is no light for night. And if it is a night type, then in the light type it is no light in both of the cases. So, that is how this SPI is going to give the information. Then caution indicators. The caution indicators defines the caution order in effect, what type of a caution is to be given. So, this is a type of a caution we are going to give. So, this indicator says there is a caution here. Indicates towards the track on which the certain restrictions are imposed, which can be temporary or permanent in nature. Now, it is indicating towards this side. It means if there is a track being provided here, this restriction applies to this track. It is placed 700 meters before the speed limit indicator. So, if there is a speed limit, it will be 700 meters before that, and it will indicate that what type of speed limit is there. So, there is a speed limit board will be there. Say 10 kilometers per hour is the speed limit with which you can move on the right hand side track, or it is 800 meter before the actual point of any permanent way walk. Grade indicators. The grade indicators, they indicate the gradient on which the track is being laid. Say it is 1 in 150 downgrade. So, your track is going in this direction. So, there will be an indicator here and which will be pointing towards the downgrade. That is how. So, you see in this photograph. In this photograph, though this has broken down and it has the lower one is lying here, it says in this direction it is 1 in 20, but in this direction, the other direction, it is 1 in 13.55. So, this is it's a quite a steep one, and this is a photograph which I have taken on a Ooty section, which is having such a steep gradients, and these steep gradients, after the train has moved on these gradients, then it has to be stopped at the one particular station for cooling of the rails, for cooling of the wheels, for cooling of the engine for 10 minutes. And at that point you can see how much amount of fumes are coming out of that. Now, sometimes V is used instead of an arrow. When it is provided without an arrow with only letter L, that indicates the end of grade and the start of leveled track. As soon as on some section it comes out to be written as L like this, that means now you are approaching the leveled track. This is a ground level sign which can be on a concrete slab base. As you can see here, it is not on a concrete slab base. There is a angle iron on which the two sheets have been welded. Then route indicators. A route indicator can be of stencil type, multi-lamp type or a junction type. Now, what are the utilities of these? We will talk about it. Now, two aspect color light signaling system may have route indicators of any design. Now, multiple aspect color light signaling may have direction or junction type roof indicator for speeds more than 50 kilometers per hour. In fact, this can also be used for any speed limit, because if it is being allowed for more than 15 kilometer, then any value can be there. Whereas in the case of MECL signaling, the speed not exceeding 15 kilometers, any approved route indicator design can be used, usually stencil type or multi-lamp type, they are being used in that. So, here you can see that what type of route indicators are there. This one is a direction or a junction type, can be used for any of the speeds. So, this is telling that which particular directional line can be taken up. This is multi-lamp type, but then this multi-lamp type, the lights will come on the basis of again which particular line is to be occupied, but the speed limits here are 15 kilometer per hour. Similarly, this is a stencil type, will come in the form of some information, and the speed restriction in this case also is 15 kilometer per hour. Then stop indicator, this is a stop indicator, there is a this rectangular plate with white and red patch things provided on it. So, you have vertical bands of red along with the circular bands in between, and that defines that this is a stop condition used under temporary or the permanent engineering restrictions when they are imposed, when the different type of say the repairs etc. are going on, or if it is a requirement to call a train to a dead stop condition before proceeding at any of the location, then also this can be utilized. There is another indicator which is a whistle or whistle at level crossing indicators. Now, this is a mandatory thing. If you are reaching a level crossing, then at least some distance before itself this whistle is to be blown, and it will be continuously blown till again the certain distance is being crossed after the level crossing, and that distance is 250 meters away. So, it means roughly in a distance of 250 meter before and after, for 500 meters the loco pilot has to blow the whistle to warn the people that you should not cross the road, otherwise there can be a eventuality. And this is defined in terms of W. That means in this particular location you need to blow the whistle. If it is W by L, that means you are approaching a level crossing, kindly blow the whistle. And if it is say WB, then that means you are approaching a bridge, again it says blow the whistle in that case. Here it is written in Hindi, so it is C fa, it means CT, you are approaching a fatak. So, that is how the information given. So, these two are the same thing. Speed limit indicator, we already talked about that if it is a triangle with 10 written on it means it is a 10 kilometers per hour speed which is being defined. It is a yellow board with a black text on it. There can be a blue board with a white text which is used for Rajdhani and Shatabdi trains and their tracks. If this type of piece is available and you see that, then that is a level crossing indicator. That means you are approaching a level crossing. Shunting limit boards. Now, shunting limit boards, they are placed at such shunting distances from the outermost facing point as the local conditions may require, and shall not be less than 400 meters or 180 meters from the opposing first stop signal. The first stop signal in short is also written as FSS. So, if you get across this terminology FSS, that means first stop signal. In two aspect or multi aspect signaling, that means in the case of two aspect it is 400 meters, in the case of multi aspect it is 180 meters from that. Shunting limit boards demarks the station section and the block section. That means that is a limit beyond which now the sections are changing, and therefore their functional conditions are also changing. This is one type of a shunting limit board which is usually used. So, beyond this the shunting cannot be done. Block section limit board, BSLB, the design is same, the information is different at the bottom. These boards are provided on double line in multiple aspect signaling territory to distinguish the limit of the block sections. It shall be provided at a station where there are no facing points or the outermost points at the approaching ends are trailing. It shall be placed at a distance not less than 180 meters from the home signal and protect the following. We discussed about it in the previous lecture also. We have seen a diagram where how the different type of signals were placed, and there we talked about the station limits, we talked about block limits, we talked about block overlaps, station overlaps. So, this you have to correlate with that. Then passenger warning boards. So, this is a passenger warning board, but it says passenger warning board shall be located at not less than 1 kilometer in the rear of the first stop signal. In the case of multi-aspect one, the distant signals are provided and the passenger warning board is not required in that case. The other one is a goods warning board, and this goods warning board, this shall be located not less than 1.4 kilometers of the rear of the first stop signal. So, a big distance is being taken in this case, and the distance may be increased suitably on the falling gradients on approaches to stations. You are coming down, so the distance needs to be increased in those cases with the provision of the second distant signal, and in those cases then this board may not be required. We can work with the distant signals. Then on Rajdhani and Shatabdi routes, the board for passenger and goods trains shall not be at a distance less than 1.5 kilometers in the rear of the FSS or in the rear of the gate signal. Gate signal means the location where certain gates are being provided and there is a certain crossing by some other modes. This is increased to 1.7 kilometers on the falling gradients if the falling gradient is 1 in 200 or more than 1 in 200. So, that distance has to be increased because of the momentum which the train is going to generate when it is coming on the downgrade. Another one is the sideboard indicator. This sideboard indicator warns the loco pilot of a signal ahead. This is for the goods train. It is placed 1200 meters ahead of the stop signal. So, for passenger trains, it is provided with alternate black and yellow strips and placed at 1000 meters before the stop signal. Shunt limit terminator, we already discussed about that in terms of a board. So, it indicates and of the shunting section. Sometimes S by L is used instead of shunting limit. So, it says shunting limit. So, instead of that it will be S by L. Placed at 400 meters to the rear of the FSS in the lower quadrant system or 180 meters in the case of upper quadrant or multi-aspect system. Then there are some terminators in terms of the passenger train or goods train limit terminators. So, these indicate the termination of the speed zone for the different type of trains. They are available in different forms. Say TEMU, this is a indicator, the terminator of EMU type which is used on the suburban trains, EMU 9, box and wagons. So, all different type of information can be given in this form. This is for points termination for the point indication and this is for the gate indication G. Here are some of the markers which we have already discussed about it and just compilation of that. If it is A on a whiteboard, it is defining auto signal. Sometimes you will find there is a black with A written on it, it is a semi-automatic signal, but it goes here, there can be some other thing being provided on this main post. Calling on signal defined by C, permissive defined by P, the distant signals. In those cases we have seen that this type of disk was attached. Intermediate block signals IB, again I have talked about this. Then repeating signal R, gate signal G with the yellow background and G with a yellow background and A with the black background, that is gate signals in the auto territory, automatic system condition. So, with this we close our discussion now. Today we discussed about the various subsidiary signals which are used on Indian Railways. To name them like shunt signals, calling on signals, repeating signals, co-acting signals. And then we talked about the various indicators, the boards, terminators. They were related with points, speeds, shunting, stop, grid, etc. So, all of this information together, that makes the type of the signals which are provided on the Indian Railways. So, we close here. Thank you. We will be meeting in the next lecture. Till then, bye.